Thank you very much. A plus B, again plus D.
Yes.
And simplifying that, can I say it is the same as A plus 2D?
Yeah.
Who has seen the fourth term in the same sense?
A plus 3D.
It is going to be A plus 3D. Let's do one more term. Let's look out for the 50th term. How is the 50th term?
A plus 4D.
A plus
Yeah.
4D.
A plus 4D. What do we notice? This is what I notice.
We keep
Okay, let me start from. It is the same as getting A plus 2 minus 1
So you have lost network.
into D. Really? I think that is not correct. That is not correct. Please sort your side. Mine is okay. Mine is okay, but we can let other colleagues confirm what is happening.
It's stable now. Thank you.
I'm okay on my side as well.
My brother, it is a problem on your end. Can you try refreshing, maybe disconnect and reconnect? Okay, I was still giving a generic interpretation. Okay, when you look at the third term, the third term is A plus 3, third term minus 1D. Are we not seeing that? If I'm looking at a fourth term, it is A plus 4, fourth term minus 1D. The fifth one is A plus 5 minus 1D. Do you observe that? Okay, so we can generally speculate that even if someone wanted the 10th term, okay, even if someone wanted the 10th term, who can guess how the 10th term will look like?
A plus 9D.
Perfect. If I look at the 10th term, it is going to be A plus 9D, meaning it is obtained from A plus the 10th term, 10 minus 1 what? D. In the same sense, can someone speculate for us the 20th term?
A plus 19D.
A plus 19D. This means it is obtained from A plus 20 minus 1D. What do we observe? Symmetrically, we can obtain the nth term, the general expression for the nth term. Can someone speculate for us how this nth term, nth term is going to look like?
Nine star. Nine star.
Nth, letter N. What do you think the nth term is going to look like based on what we've seen above there?
I think
perfect. It is going to be A plus N minus 1D. And this expression is very important when we are talking about arithmetic sequences. Okay? And if that is making sense, we are now going to look at some examples and you see what I'm talking about. Okay? Now, consider these examples. 1, we are given a sequence of 3, 9, 15, 21, and so on and so forth. Okay, and someone is telling you, please find the 20th term. Okay. Yes, however much we know that we are adding 66, correct?
Yes.
You come here, but you add what? 6.
6.
You come here, you add what? 6. Come here, you add what? 6. How many times are you going to keep adding until when you get the 20th term? Even the 20th is close, assuming someone wanted you to give the 150th term. Okay? Assuming someone wanted you to get this, how are you going to get it? You must use the expression for the nth term. Okay? From here, we already said that we can see that our first term, excuse me, we can see that our first term, which is A, is equivalent to 3. Is everyone seeing that?
Yes.
Yes, we can see that the common difference, what's the common difference?
6.
D is 6. But we've just seen from above that the nth term, okay, the nth term is going to be equivalent to A plus N minus 1 what? D. Okay, so if they want the 20th term, like the question is saying, it is going to be A, which A is 3, plus N, which N is 20, minus 1 times D, which is 6. Okay, and this one should give us 117. You can look at it and simplify it. Give me 1 minute to be back as you internalize that solution. Let me make it sure everything is visible. Yeah, that one. Okay. Any questions about that example? Is it making sense to us? Okay. Thank you very much. Let's have another example. Let's have another example. Let's have another example. Example 2. Yes, example 2 is for you to try out, and I see how people can actually reason out things. They are telling us that find the 36th term. I'm just going to summarize the question. Find the 36th term, okay, of the arithmetic sequence whose third term is 7 and 8th term is 17. Can someone give us an idea of what he or she thinks can be the approach to this? Perfect. He's saying we need to look out. He's saying that we need to consider the third term. And we know the third term, like we said earlier, it is going to be A plus 2D, which is equivalent to 7. We say equation 1. Eighth term is A plus 7D, correct? equals to 17. This is equation 2. And he has said that we need to solve these equations. They are simultaneous equations. Solve the simultaneous equations, okay, to find A and a B, correct? Then use the nth term expression, which is A plus n minus 1 into D, to find the 36th term. Yes, what you have said is the correct thing, and I have nothing to add to it. Can I give you 2 minutes to get that solved and tell me the answer? Hmm? I'm giving you 2 minutes to tell me that answer.
Sir, D is 5.
Someone is saying D is 5. D is 5, really? Do we know how to solve simultaneous equations?
D is 2, sir.
D is 2 and A is 3. That is correct. Others, make sure you get that. So solution, D equals 2, A equals 3. Can I get the value for the 36th term?
A, 3 plus N.
The one who has got 5, can you give it another try? This one is 36, is 73. That is correct. So we still need more people to tell us if they have got the same answers. Others, please. Others, please tell me.
$73, sir.
Okay, good. Others, thank you. Good. Others. Others, do you want me to just proceed? I just proceed. It is important that people respond and tell us what they have got if they really want to follow through with us. Okay, it's fine. Let's proceed. Are you guys there?
Yes.
Okay, let's proceed. If other people can't respond, of course, I have no way of telling. Let's just proceed. Let's look at the second type of sequences, and that is geometric, geo. Now, like I mentioned, here is one in which every term, okay, geometric sequence is a sequence in which every term after the first term, okay, is obtained from the preceding term. From this preceding term by multiplying by a constant. Multiplying it with a constant. So for arithmetic sequence, we've seen that we just added. Okay? We just added. Here we multiply. Okay? It should also be noted that a geometric sequence, it should also be noted that a geometric sequence, okay, is also called a geometric progression. Geometric progression. Okay, this is the same name. Sometimes we just abbreviate it as GP, geometric progression. Similarly, the arithmetic sequence can also be called arithmetic progression. The constant number we multiply, okay, that constant number we keep multiplying is called the common ratio. No. Yes, it is called the common ratio. As well as we call it a common difference in AP, arithmetic progression. Here we call it common ratio. And this common ratio is always denoted by letter R. Okay, is always denoted by letter R. We can have an example here. If I had a sequence like 1, 2, 4, 8, and 16, and so on, okay, this is a GP, because you will realize, okay, that to get here, we multiply by 2. Okay, to get here, we multiply by 2. To get here, we still do the same. To get here, we still do the same. You keep multiplying by 2, multiplying by 2, multiplying by 2, and so on and so forth. Ideally, if we want to find out that a specific sequence is a GP, okay, the other option will be to divide. This is 2 divided by 1. No. Yes, if you get 2 divided by 1, what do you get? 2 over 1, you get 2. If you get 4 divided by 2, you still get a 2. If you get 8 divided by a 4, you get a 2. If you get a 16 divided by a 2, you get a 2. So I'm just emphasizing how best you can test to determine if this one is a common ratio, or if this one is a geometric progression or not. Okay, does that make sense? Are we good?
Yes.
Great. Now, if we look at the generic representation, no. If we look at the generic representation of a geometric progression, okay, this is not good for me. I need first create space. Okay, if you look at a geometric progression, let's consider, let A be the first term, okay, and R be the common, okay? According to what you've seen, our first term is going to be what? Is going to be A. Making sense? Who can guess for us the second term based on this example? But in terms of A and R. Any input there? Good. It is going to be A times R. Okay, and actually that one is also well evident based on my explanation here, that a geometric sequence is one in which every term after the first term is obtained from the preceding term by multiplying it with a constant. And this constant is actually called a common ratio. Okay, so thank you very much. The second term is going to be A R. Can someone guess the third term?
I think the third term should be A times 2R.
It should be AR squared, because it is going, we keep multiplying by 2 by 2 by R by R and by R. So what about the fourth term? It is going to be AR cubed. When you look at this one for the second term, you will realize that it is going to be AR 2 minus 1. If it is a third term, it is going to be AR, the third term, 3 minus 1. If it is the fourth term, it is AR 4 minus 1. From this kind of symmetry, we can even predict the 10th term to be what expression can we get for the 10th term? Following this notation that it is going to be AR 10 minus 1, it is giving us AR power 9. And by symmetry, we can still obtain the nth term expression and say that our nth term is going to be, can anyone generate for us the nth term based on what we have seen above there? It is going to be ARN minus 1. This is the generic key. This one is the general representation of sequences in GP. Even if someone told you that please find the 200th term of a geometric progression or a geometric sequence, you can still use this kind of expression to come out to get any term needed. To get any term needed. Okay. That is it. Can we see a few examples? Can we see a few examples? Yes. Look at this. They want us examples. They want us, one, find the eighth term. Find the eighth term of the GP 4, 12, 36, 108, and so many other terms. Can you guys give it a try? Can we give it a try? I'm waiting. Let people try out and we see what they can get. I can note the answers here for the different people. A is 8. $875. Please, I'm not hearing you very well. I don't know what's wrong with your echo. There are some echoes, I think, in the background. I can't get it.
Check the message.
$8748. Good. 8748. I see Emmanuel, Raymond get the same. Emmanuel get the same. Abdulrahman got the same. Anyone with a different answer?
No.
Okay, let's assume this is the correct answer, but let's try to do it together. Okay, just so they want us to find the eighth term. But remember, we said that for a GP, the nth term is equivalent to F R N minus 1. Okay, and here we have our A as 4, and we have our ratio as, what's our common ratio?
It is 3.
3.
It is 3. For those who don't know how 3 has been obtained, like I said, this is 12 over 4. This one can be 36 over 12. This one can be 108 over 36. And all those 3 must give us the same answer, which is 3. Eventually, we want to find the eighth term. So the eighth term is going to be AR 8 minus 1, which is AR 7. we have our A as 4 times 3 raised to the power of 7. And I'm very optimistic. This one should give us 8748, like all other colleagues have got it. Questions for me? Okay, if people don't want to respond, it's fine. Example, I think, 2. Okay, let's look at example 2. For example 2, check this. For example 2, I think you can try it out later on. Yeah. Just note these. You can try them out later during your free time. In fact, they are in the notes. Just open your notes. You'll find slide 27. There is a question on slide 26 and slide 27. There is a question on slide 26 and slide 26 and 27. Now, whatever we have been going through, now we need to know how to generate explicit formula or general. Okay, previously we've seen a number of examples. For example, where we have seen a number of examples.
Excuse me, sir.
Yes.
So you're saying we should get the notes from where? V-Class or there's somewhere where you're uploading the notes? Because from V-Class, there's nothing there.
Notes are there. Your colleagues can attest to that.
Really?
Maybe sir, if we are to be specific, which lecture? Because there is lecture 1, 2, 3, and 5, 4, 5.
But sorry to ask you this. Have you guys been attending the classes and have you checked through all those lectures? Sincerely, let's try to be serious. I started by teaching differentiation and explicit formulas. Earlier on, we've seen examples. Where the first one actually we are given k over, was it k plus 1, where k is greater or equal to 1. And we generated the terms of such a sequence. Okay, and we generated terms of such a sequence and obtain it. We obtain the sequence as 1 over 2, as 2 over 3, as 3 over 4, as 4 over 5, and so many other terms. I'm just quoting this example. When you're given such an explicit formula, you should be able to derive a sequence. Is that making sense? But again, you can be given a sequence and you are expected to get that formula. So, under this section, we want to see how do we generate explicit formula or general formula from a sequence. Okay, how do we do that? How do we do that? Are we good? Are we together? Are we together?
Yes.
Yes, sir.
Okay. Now, if that is correct, we are going to see some examples of how it is done because we have already actually seen it by looking at the general expressions for the geometric progression and arithmetic progression. Take this example, okay? For straight, let me just to say 2, 4, 6, 8, and so on and so forth. We said that the nth term, okay, after confirming that this is an AP, this is an AP. After confirming that that is an AP, we shall strictly, in fact, because when you are given an expression like this and you're told to find, the explicit formula, we don't know. We don't know if this is an AP or a GP. So always the first thing is to find out. Okay, this is 246, 246, 8, 10, and so on. You will realize that here I add a 2. Here I also add a what? A 2. I do add a 2. I do add a 2. So we are seeing a common difference, correct? B, which is equivalent to 2. And we are also seeing the first term, A, which is a 2. Okay? Then, from the nth term, expression, we can say that our AN is going to be equivalent to A plus N minus 1 D. That's what we say is the expression for the nth term. Correct? Are we there?
Yes, sir, we are there.
Okay. So this means that my AN is going to be 2 plus N minus 1 into 2. Actually, we can leave our answer as that, or we can proceed to simplify to 2 plus 2n minus 2. You see? And my AN is going to be n. This one is going to be taken as the explicit formula. In other words, we use the nth term expression to generate the explicit formula for an IP sequence or GP. Likewise, even if you identify it as a GP, we shall still use the same approach. However, check this. We are given AK equals K over K plus 1, where K is greater or equal to 1. Meaning, we must really get the integer, the domain of the integer range values. Okay? For example, here we can say where n is greater or equal to 1. You might ask me how I have got that. So ideally, the explicit formula will be an equals to 2n, okay, where n is greater or equal to 1. Okay, and when you expand this, you can actually get the answer. When you expand this, you can actually get the answer. Because here n is going to take on values 1, 2, 3, 4, and so on. When you substitute for n equals 1, you should be able to get a 2. When you substitute for n equals 2, you should be able to get that. For n equals 3, that one. For n equals 4, that one. And the process continues. So ideally, when you're given a formula, like in this example, when you're given a formula, you should actually be able to generate, expand it, and generate out a sequence. Also, when you're given just a sequence, you should be able to generate what we call an explicit formula. Does that make sense? It is basically nothing apart from just using the NF term expression. Are we okay, guys? We just used the NF term expression. Okay, good. People are responding here in text and okay, okay. Now, as I almost get to the end of this, we have seen this example. That has been the example when it comes to the NF term. So ideally, for every single example, you need to identify if this is an AP or a GP. Once you conclude about that, then you can use the NF term expression. Another consideration. Actually, this should be noted. Note. Explicit formulas, all general formulas are actually functions. These are functions. To be more specific, they can be polynomial. They can be polynomial what? Polynomial functions. Polynomial functions take a form. We have the first one is called a constant polynomial function. I talked about this. I'm just re-echoing them. The next one is a linear. A linear function takes form ax plus b. Then we have a quadratic one which takes form ax squared plus bx plus csc, and then so on and so forth. Now, whenever you get to the equilibrium, we always call it equilibrium point. Whenever we get to the equilibrium point on the first go, that equation must be a linear equation. It must be of this form. But there are some other examples, okay? There are some other examples. I think this is what I'm talking about. There are some other examples. Let's just have another example that goes to level 2. Okay, let's have another example that goes to level 2. Guys, look out for this example. In fact, in mathematics, sometimes you just need to apply logic. Okay, sequence. What some? Where have I stopped? Okay, here. Look at this example, guys. Example 2. We are given a sequence 2, okay, 6, okay, 12, 20, 30, 42, and so on and so forth. See what is going to happen. When we get a common difference here, what is the common difference? It is going to be 4. 6 minus 2 is a 4, correct? Okay. If you look at 12 minus 6 is what? 6. Good. When you look at this one, you get a 8.
8.
When you look at this one, we get a 10. When you look at this one, we get a 12, correct?
Yes.
So at level 1, we have not got the equilibrium point. We can still proceed and look at the second level. What is the difference here? It is a 2. What is the difference here? It is a 2. What is the difference here? It is a 2. And it is a 2. So we have reached the second level. Does that make sense? We have reached the second level. It is possible that we reach the third level, fourth level, and so on. But no worries, for this level, we are only interested at the second level. Okay? Now, what does this mean? Since equilibrium point is reached, okay, is reached at level 2. This means that my, oh, not my, sorry. This means that the explicit function, explicit formula follows a quadratic equation. Not equation, follows a quadratic function of form ax. No, we are using n. We can use n of form an squared plus bn plus c. That is the generic representation of the equation of the explicit formula we expect to have. Okay? And at this point, we need to substitute, get values of n equals 1, n equals 2, because we expect this to be, okay, we expect this to be, what's up? The thing's not working. Okay. Oh, yeah. Okay, here. I hope we are together. I hope we are together. We are on the same page. Okay, good. Someone has responded. Now, see what we are going to find. Look at our first term. Can I say my first term? Our first term is 2, correct? Second term is what? Is 6. Then we also have the third term as 12. 2, 6, 12. Okay? According to the generic representation, this one happens when n is 1. This one happens when n is 2. This one happens when n is 3. Okay? And from here, principally, this is what you're going to find. Here, you're going to find a plus b plus c equals a 2. If I substitute for n equals 2, I'll get 4a plus 2b plus c equals a 6. And here I'll get 9a plus 3b plus c equals a 12. I have equation 1, I have equation 2, I have equation 3. Meaning, we need, this one is the explicit formula. You need to find the values of A, values of B, values of C. Substitute in that equation and then be able to get the expression AN equals, get the expression.
So how did you get 4n to be?
Okay, check this. Okay, we have said, no worries, I'm going to repeat. We have said that our expression means an squared plus bn plus c. This is the conclusion we reached. From where? Because we reached the equilibrium point at level 2. Therefore, it should be a quadratic equation. Here, for level 1, it should always be a linear equation of that form. For level 2, it should be, we can call this n, a quadratic equation of this form. If it was level 3, it would have been n cubed plus bn squared plus cn plus d. It would have been a cubic equation. It would have been a cubic equation. Now that it is a quadratic equation of this form, 1, when n is 1, for the first term, we shall say, when n is 1, we shall get the first term, which first term is a1, which is equivalent. We substitute 1 there. You get a plus b plus c, which is the first term that is equivalent to 2. Second term is 6. Third term is 12. So this is going to be 2. When n is 2, we are getting the second term a2, which a2, if we substitute 2 there, 2 squared is 4. So I'll get 4a plus 2 times b, 2b, plus a c equals a 6. And finally, when n is 3, we shall get a 3, which is 3 squared is 9, hence 9a, plus 3b, plus a c equals a 12. And we are going to solve this equation. We have to solve those equations to get the answer. For example, let's get equation 2 minus equation 1. You will realize if I do it that way, I'll get equation 3a plus b equals 4. Is everyone seeing that? This one can be my equation 4. I'm getting equation 2 minus equation 1. Here we are just applying a technique of solving simultaneous equations. Then what about if I got equation 3 minus equation 2? If I get equation 3 minus equation 2, I will get 5a plus b equals 12 minus 6, you get a 6. Okay? And this can be equation 5. Now, equation 4. 4 and 5 are simultaneous equations, which can be solved. And once you actually to solve them, since we have PP, we can just subtract. If you get equation 5 minus equation 4, you will get 2a equals 2. Okay, and from here we can get our a as 1. This is obtained. If you substitute in any of those equations, you will get your b as 1 as well, I can see. Then if you get ab and substitute in equation 1 over here, if I say, if I substitute a equals 1 and b equals 1 into 1. 1 was a plus b plus c equals 2. We shall get our c as 0. Hence, from the generic expression where we say the an equals to an squared plus bn plus c, we can substitute for all these values and finally come up with an as n squared plus n. Because a is 1, b is 1, and c is 0. This would be the generic expression. However, we need to get the answer. So we need to get the range. And the range is always n greater or equal to 1. So you can test out this and see if when you expand this, you actually get the sequence above. So ideally, that's what happens with the sequences and we just need to give it practice. We have a few examples in the, oh, what's up? Okay, therefore we would conclude that the explicit formula, the explicit formula is an equals to n squared plus n, where n is greater or equal to 1. And our scope is basically going to be limited to arithmetic sequences and geometric sequences. Harmonic ones we shall not talk about later. Actually, let me save this file before it is lost. You might want it maybe to supplement on the lecture, on the presentation. I don't know if you need it. If you need it, I can share it. Let me see if I
We need it.
I think I've overtalked. I need to leave the remaining time for you to practice. You think I can sequences? Let me save it. Maybe on this flash case. Okay, I'm trying to save this work and share it on your